Okay, question 10 in the written response. Here we go. This is a full-on, let's sketch this thing. Okay, so our expression here is x squared over x plus 3. So first thing we're going to do is identify the domain. The domain is quite simple here. The domain of our function is going to be the set of x values such that x does not equal negative 3. Now, you don't have to necessarily write it out like that, but it's a good idea to be familiar with the notation. B, intercepts. Now let's find the x-intercept first, because that's the hard one. That is going to be where the y-coordinate of the point is equal to 0. So 0 is equal to x squared over x plus 3. Well, the denominator has no impact on that whatsoever, so you bring that up here, and that is going to be x equals 0. If you want to find the y-intercept, we're simply going to let the x equal 0, so y is equal to 0 squared over 0 plus 3, y equals 0. So really the issue here is the origin. Okay? C. Okay, I'm going to just move this over here because I want to give myself a fair bit of room down here. C, if I'm not mistaken, was asymptotes. And so in this case right here, we're going to have a vertical asymptote at x equals negative 3, okay, because that's going to correspond to our undefined value there, the break in the domain. The degree of the numerator is larger than the degree of the denominator, so we're not going to get a horizontal asymptote, we're going to get a slant asymptote. Okay, so we're going to get a slant asymptote at, and, well, it looks to me like we're going to have to do some division here. So I'm going to take and divide. I'm going to do my, I'll do synthetic division because it's whatever, it's fine. So negative 3, and I'm going to go in, and the reason I want to do synthetic division because I like how this is going to look. This is going to end up being 1, 0, 0. This is just, I don't know why I thought that was entertaining, but it is. So bring down the 1, multiply by negative 3, and then add negative 3. Negative 3 times negative 3 is 9. Add, and I get 9 here. So this is my remainder. Okay, now if you think about the way these are going to be written here, this is my quotient here is going to be x minus 3, and then I would have this 9 still that would be divided by that x plus 3. So that part there, when we take the limit as x goes to infinity, this is going to drop to 0. This becomes the dominant term. And so we're getting this expression here, x minus 3 is our slant asymptote. Okay. Now part D, symmetry. Okay, if I plug a negative into that, okay, if I go y is equal to negative x squared over negative x plus 3, the numerator becomes x squared. If I try to take the negative out of the denominator, I'm going to end up with x minus 3. It's not the same here, so this is neither odd nor even. Okay? Now, good start here. Now we're at E. We're going to determine the intervals of increase and decrease. Okay? So it means we're going to take the first derivative, and that is going to end up being, it's a rational, so I'm going to use the quotient rule here. So it'll be 2x times x plus 3 minus x squared all over x plus 3 squared. Okay, so expanding out the numerator, that's 2x squared plus 6x minus x squared all over x plus 3 squared. Okay, that's going to be x squared plus 6x all over x plus 3 squared. When I simplify that, now I am looking for critical numbers here, which could be where the expression here goes to 0 or is undefined. Now, where it's undefined doesn't count as a critical number because that negative 3 was not part of the domain. However, it's still a number that I need to consider here. The numerator is going to go to 0 when x is equal to 0 or negative 6. And I hope you can see that just by factoring out the x here. And then we're going to get negative 3 as an issue there as well. Now, along the number line here, that's going to be negative 6, negative 3, and 0. So we're going to just determine the intervals here. If I plug in a number less than negative 6, let's say, I don't know, let's say negative 10, that'll become 100 and, what is it, minus 60, so it'll become positive 40, and then the denominator is always positive, so this will become positive. So it's increasing there. Between negative 6 and negative 3, I don't know, like pick like negative 5. Again, the denominator stays positive, but at negative 5, this will become 25 minus 30, so that'll be negative. If you pick a number between negative 3 and 0, like negative 1, again, the denominator stays positive, but negative 1 squared is going to be 1, and that's going to be negative there as well. And if you choose a number bigger than 0, like positive 1, then everything here becomes positive. So this thing is increasing on negative infinity to negative 6, union 0 out to infinity, and decreasing on negative 6 to negative 3, union negative 3 to 0. Okay, now we're quickly going to identify part F here, which means just going through and identifying what these values are. Remember, negative 3 is this vertical asymptote here. So I've got, it's increasing and then decreasing to negative 6. So I have got a max at negative 6 comma, whoops, can't hardly see that. I'll go up here. Okay, negative 6 squared, whoops, sorry, negative 6 squared is 36. Negative 6 plus 3 is negative 3, so 36 over negative 3 is going to be negative 12. And because it decreases to 0, then increases again, I'm going to get a min at, and I already know that that point is 0, 0. Okay, good. Now I've already got basically everything I need to sketch this thing. But we're going to go through and just take a quick look at the intervals of concavity as well, because we need to. So my second derivative here, if I take the derivative of the derivative, is going to be 2x plus 6 times x plus 3 squared minus x squared plus 6x times 2x plus 3 all over x plus 3 squared. Okay, well, instead of expanding that all out, I'm going to factor out a couple of things here. I notice that I can take out, for example, an x plus 3 from here and here, and then notice I've got a common factor of 2 here. I'm going to take it out there as well. So I'm going to take out a 2x plus 3. That's going to leave me with x plus 3 times x plus 3, so x squared plus 6x plus 9. Over here I took that out. This is going to be minus x squared minus 6x, and I really like what I see going on there. And then this will be over x plus 3 squared. The x plus 3 over the x plus 3 is going to cancel here, and I'm left with 2 times, now I like that, the x squared goes away, the 6x goes away. That just couldn't have been any prettier. And so this becomes 18 over x plus 3. That's just a dream. That's just absolutely amazing. The only issue here is where this thing goes to, it becomes undefined at negative 3. And because that was a vertical asymptote, that doesn't end up being a point of inflection, so I don't even have to worry about that. To the left of negative 3, this is going to be concave. Whoops. Oh, that was terrible. After all those times that I did that for you guys, I did that wrong. This is going to be concave down, but over here it'll be concave up. So concave down, okay, negative infinity to negative 3, concave up, negative 3 to infinity. Okay, now, part H. What does this look like? Okay, well, we know that we've got a minimum at 0, 0, and we've got a maximum at negative 6, negative 12. So negative 6, negative 12, somewhere down here. There's my maximum. Okay, so minimum, maximum. Sorry, something like that. Along the top here, I know that I've got intervals of increasing here. It's going to increase. Basically, at negative 6, it changes. Okay, at negative 3, it changes. So here's negative 6, negative 3, and at 0, it changes. And it's what we've got here is increasing, decreasing. Oops, I should write it like this. Decreasing. This is decreasing, and then from here on, it's increasing again. Okay. My concavity only changes at negative 3. It's concave down here, concave up over here. Got to remember my asymptotes. Can't forget about those. I've got a vertical asymptote at negative 3, okay, which explains the changes there. But I've also got this asymptote here at x minus 3. So minus 3 is going to be, it's going to be like here, and this thing's going to end up looking like that. So now putting this all together, in the interval to the left of -6, I've got this asymptote here. It's increasing and concave down. So it's going to approach the asymptote like this. Then it's decreasing and concave down. It's going to hit here and drop down like that. Then I hit the asymptote. I'm decreasing and concave up. There's a vertical asymptote there, so it's going to come down like this to that point. And then it's increasing and concave up, but there's an asymptote there, so it's going to come up like this and approach the asymptote. And that's what that function is going to look like.